Alright, so I do kind of want to keep this video brief because it is just going to be me yapping about issues. I've had an enormous number of problems specifically over the last 4 months, but also kind of stretching back to an entire year at this point. All realistically to do with Mushies foot pads and then also PPACF casing printing. So I'll talk about both today, but we'll get into foot pads first. So Mushies foot pads, which have been used by heaps of people, these things have had an issue for an extremely long time now of sensors getting stuck on a half, which ends up in ghosting issues, dismount issues, just destroys the functionality of the board. It makes things dangerous, so I've not wanted that to be a problem. And I've done an enormous amount of experimentation to try and work out why it's happening, how to fix it and stop it. And the results were honestly extremely surprising to me, but I feel confident enough now with the amount of stuff that I've tried to have a solid answer. Started about a year ago, once like lots of people were starting to use these pads. I'd say about 10 to 15% of them ended up with a sensor that would be stuck on one half. And it was interesting because this wasn't after a specific period of time. In the last year or so, I've had pads where they've been stuck not instantly after construction, but after literally 20 minutes of riding, they'll end up stuck on one side. I've had some pads that have lasted forever and been completely fine, and then other pads, you know, might be a few days, maybe a week or two. So it's been very difficult to track down exactly what's caused these issues. All I've really been able to do is make a heap of designs based on what could be causing the issue and just throw them out there on my boards and friends who are comfortable testing things to just see what fixes this problem. So a lot of people have pointed out that these sensors are very delicate, so flexing them too much can cause issues. Installing them on layer lines can cause pressure. There might be bubbles due to grip tape and like all of this stuff I've tested. I think it started with putting insets into the pad here. So you might be able to see the sensor shape here where there would be about just under 1 millimeter of room for the pad to sit flush with the grip tape. Of course, the thought there was grip tape was applying extra pressure around the edges. Of course, I tried that, still ended up with sensors getting stuck on one half, so I knew it wasn't that. I have tried perforating the grip tape so that bubbles don't form and air can freely escape. I've ended up with just as many stuck sensors with perforated grip tape as I have grip tape that I haven't touched. I've also tried attempting to put the sensor on a completely flat surface so that there's no layer lines creating extra pressure. Still ended up with stuck sensors doing that. I have tried placing a barrier between the sensor and the grip tape such that there is absolutely no adhesive on the top side of the sensor, and then that's not going to get things completely stuck or pressed, and that has also ended up with sensors getting stuck. I have tried both flat plates and concave plates that are solid, so not squishy like normal TPU, but I've tried mounting this on a PCTG plate and still ended up with sensors getting stuck on their halves. So realistically, I had absolutely no idea what to do until about 2 months ago. Thinking I tried absolutely everything. I'd spent ages chatting to Carlos at Stokestock, who created these sensors. He didn't know what was going on because I tried everything he told me to do in terms of sensor installation techniques and trying different pressures and that kind of thing. And it turned out I had to sit down with my friend Robert, who is fantastic with electronics. He spent like half an hour on my workbench while I was like over here working on other boards or something along those lines, and he had a multimeter hooked up to a sensor which had half of its side stuck, and he found that pressing very specifically with a pin into the corner on this finger caused the sensor's resistance to suddenly change drastically. So he made a pretty crazy discovery when he cut the very tip of the corner of this finger, and suddenly the entire sensor half started working normally again. This kind of blew us away. We started applying this modification to every single sensor that I had stuck on the shelf, and all of them started working again. I had about 5 sat around on the shelf. I applied this modification, boom, all of them started working. So I chatted to Carlos again about this issue, and he said that he believes the potential difference in air pressure between the factory where these are made and then like the local air pressures of where these sensors end up could potentially cause a pressure difference in between the layers of this sensor and the outside. So snipping just a tiny bit of the corner here exposes the air and allows the sensor to regulate itself again. I have no idea if that's the truth, but applying this technique ends up fixing them. So why it works, I don't know. And after we worked that out, I suddenly jumped into every single technique I could think of to try and make a sensor which could be easily removed from the foot pad so that you could modify it in case of a stuck situation or just a general replacement. So I started coming up with ideas like this, where you have basically an outer TPU shell. The foot pad the sensor goes like this in the center, and then the grip tape gets placed over the top with a barrier between them with a sheet of TPU like this. And essentially what that's going to allow you to do is pop the sensor out from the underside, because it's only held in with a wedge. And I mean, this is just a little demonstration, but that'll let you pop the sensor out to modify it. I spent honestly about a month and a half trying to work a design like this, and it wasn't great because I kept trying different things, different materials for the different areas, and I could not get something that maintained sensitivity. I've typically used V4 sensors, which aren't the most sensitive, but they've usually worked quite well with general techniques, and I'm quite happy with them. But yeah, I couldn't get a system to work here that was sensitive enough for my liking. I kept on having a pad that would be a bit flickery while you were stood at a standstill. But I realized basically that this wasn't needed once I started using printed grip tape. The only reason I had designed something such that a sensor could pop out of the bottom of your pad is because I was used to, in my head, the idea of grip tape being completely destroyed when you went to replace your sensor. But it turns out it's completely not the same case for 3D printed grip tape. This stuff can be peeled up without heating quite easily with absolutely no destruction or stretching to the TPU. So you can see here that I'm peeling this grip tape around the edge. I'll do the other side actually, because that's where I've made the modification. Yeah, you can see that that peels up extremely easily. It might allow you then as well to make that snip modification to the side of your sensor. And then once you've done that mod, if you've encountered the same problem, you can just peel it back down, press it into place, and then that's not going to move again. So yeah, after all of this work, I've ended up basically with a design such that your sensor is sat into a recess to make it flat with the grip tape. That doesn't change the sensitivity that I found. And using 3D printed grip tape allows you to pull the grip tape up in certain areas if you need to get at your sensor, perform that cut modification to one of the fingers, and then you'll be completely set if you encounter stuck sensor issues. So yeah, what's good is whilst I've replicated this about half a dozen times in this workshop, a few of the foot pads that I've sent out already to other riders overseas, Kevin specifically, he had this exact issue. I walked him through the modification process to snip one of the fingers of the foot pad sensor, and his pad started working again magically. So I'm pretty confident in this solution, and yeah, that's basically all there is to it. So yeah, that being said though, I have also had lots of other issues foot pad related. Nothing to do with the design, but simply sourcing the components. Over the last 3 months, I have had one shipment issue where I wasn't sent the right number of foot pad plugs, and then the second large batch order of foot pad plugs I ordered got lost in post. So I finally got foot pad plug supply, the Switchcraft 6 pins, ready for foot pads last week, so I'll finally be able to start shipping them out soon. But that's another reason as to why foot pads have been so ridiculously delayed. Yeah, both design issues, solving problems, that's all sorted now, and of course component supply as well. both kind of screwed things over for the last like 4 months straight. So hopefully that adds up as a good explanation as to what's going on there. So the second thing to talk about is the difficulty printing PPACF plastic. Everything went well initially during my early tuning and testing phases. This stuff is still magical, but the extreme strength of this material started to wear pretty heavily on my 3D printers once I'd started getting into producing in larger amounts. It ended up with nozzles continually breaking and getting clogged. It ended up with some pretty heavy layer shifting due to the amount of force that was being placed on the tool head, skipping belts and stuff like that. So I did an extreme amount of maintenance on my printers, replacing parts to try and keep them going, like making these components, but it just ended up continually having more and more issues. So I started, opting into other printers as well to try and supplement these issues that I was having, only to, continue to run into the same sort of things. The H2D from Bamboo Labs specifically had, I ended up with a pretty defective 0.6mm nozzle at the start, so that thing split in half and started spewing plastic everywhere. It didn't go very well. And I've also had jam issues pretty consistently with the K1 Max. So I've tried to offset these issues of, printing difficulty by using bigger nozzle diameters to reduce strain on the extruder and stuff like that. But then I end up with a lot of stringing issues, and retraction doesn't really help with that size of a nozzle. So I'm honestly still going with getting it perfectly set up such that I can still continually produce it reliably with these machines. But I'm slowly inching towards that. Right now I've got the H2D running it well with their replacement nozzle that they sent me, and I'll keep on working on it in the future, but it's just sort of been slow. So that's all there really is to say. There hasn't been a specific issue, just more and more continuous maintenance issues that keep popping up as I keep going making the stuff. But it has been pretty successful so far, just slower than I'd hoped. PCTG though is working fantastically and prints super easily, so no problems there. Everything else though has had issues as I've just gone over, slowly working through it. That's all I've really got to say, but I feel it's best to just let everyone know what's going on. And yeah, that's it. Hoping to ship a whole heap of pads this week now that I've got everything working properly. So yeah,